Okay, let's give you guys a number of examples about Lewis acid and Lewis base. Let's start with a simple one. Okay, so for this trimethyl or borane, so so the borane center, so it has 6 electrons around. It needs 2 more electrons become a stable simple octet electron configuration, right? So in this case, the ammonium has a lone pair with nitrogen. So this lone pair nitrogen can donate to the boron center, so we can form a BN adduct. So then that's a Lewis acid pair. So in this case, this is Lewis acid, and here the ammonium is Lewis base. So remember when we talk about bronzite acid between ammonium and the hydronium ion, and so we also have ammonium as a base because it has proton acceptor. So in this case, okay, the ammonia is a Lewis base because it can supply a pair of electron here. Okay, let's move on to another example. So when we talk about metal cation, so metal cation always it has empty d orbitals. It also can take up electrons. Sometimes it take up more than 1 pair. Okay, and in this case, cobalt 2+ is an acid. It can take 6 pair electrons from 6 water. Okay, so we form this coordination hexa water cobalt compound. So in this case, cobalt ion is Lewis acid, water is Lewis base. Okay, and a third example is even a molecule, so it can accept a pair of electron from another species to form a complex. So in this, CO2 is Lewis acid. It can undergo rearrangement for the electronic structures. Okay, this one is hydroxide is Lewis base. Okay, and also there's a fourth example. So we can see this tetrafluoride cyanide can accept 2 pairs of electrons from 2 fluoride. So we can form this hexo fluoride silicon anion. So here that's Lewis acid, and electron donor fluoride is Lewis base. Okay, so those are example of Lewis acid and Lewis base. So move on. We can talk about important concept about Lewis acid and Lewis base, and we call that hard Lewis acid or soft Lewis acid base. So what does that mean? So in chemistry, in inorganic chemistry, so hard acid to tend to bond with hard base strongly, and soft acid can form strong bond with soft base. So what does that mean? Let's give some example here. So in this case, so the blue line here, let's use our pen. Let's use a black one. Okay. So here the blue color one. So these 3 guys, the scandium, aluminum, indium, in blue color, they are hard Lewis acid. So when you can see when they form bonding with the hard Lewis base fluoride, so the formation constant here is large. That means they can form strong bonding interactions. Okay. On the other side, so we have soft Lewis acid. Okay, soft Lewis acid. Here is hard Lewis acid. Okay, so soft Lewis acid, they can form strong bonding with sulfate. So on this side is soft. That's soft. Here on this side is hard. Okay, it can form strong the mercury ion, okay, palladium ion or cadmium. They are soft. We said they can form strong bonding with soft halide, iodide. So you can see the formation energy is large. Okay, and also you have something between the green ones. Okay, the green ones. Okay, green ones like indium is green. Okay, and it form intermediate interaction with this base. But one more thing you will notice is when hard acid, okay, when hard acid like scandium aluminum, when they interact with sulfate, the bromide here, so you see the log K become much smaller right here, right? So we have mismatch between a hard nucleic acid with soft base or hard base with a soft acid, their interaction will be weaker. So we call it mismatch. Okay. Okay, here is a table to give you guys an example and the typical harder nucleic acid and soft nucleic acid. So, and here is acid part. And here is base part. Okay, and also we have hard nucleic base like fluoride, hydroxide, and water, ammonium, and also several other ones. And we also have sulfate nucleic base like hydride, alkene, anion, cyanide, carbon, CO, and then iodine minus. Okay, they are soft. Okay, and basic idea is they form strong bonding. Strong. Okay, hard they form strong interaction. Soft is soft, they also form strong. As I said, if we go cross, if hard to soft, okay, and hard acid will interact with hard, a soft base, the interaction is weak. Okay, same thing. If we have soft acid interact with hard base, the interaction is also weak. When we have something between, interaction is also weak. Okay, in here is also weak. Got it? And then let's give us some final explanation about the interaction between hard nucleic acid and soft nucleic acid base interaction. For hard nucleic acid base interaction, so because hard nucleic acid for acid, okay, and the base, okay, for a hard nucleic base, the electron pair is really hard to be shared. It will hold tight with the central atom of nucleic base, and for hard acid, it's really harder to polarize electron from the nucleic base. So you can imagine that's just a plus ion interact with the minus ion. So it's kind of electrostatic interactions, and minus ion and paired with plus ion. That's kind of ionic compound, but it's a strong ionic interaction there. Okay, but for sulfate acid and base interaction, okay, so the base, like give you an example, like the iodine, okay, like iodine, okay, we have lone pair here, right? So this lone pair is really floppy, okay, it's easy to polarize from this lone pair, okay. So then if we have a nucleic acid, like we talk about, like palladium 2+, okay. So the numeral of this soft nucleic acid is also soft. It's easy to polarize, and you can see it can form overlap between these two orbitals. Then we have a formation of covalent bonding between soft acid and the soft base. Okay, soft base, soft acid. Okay, so that's covalent bonding. So when you have overlap here, we know that means strong bonding here. So that means that explains why soft acid-base interaction has strong, covalent characters. It's strong bonding. Okay, so that's the difference between hard Lewis acid-base interaction and soft acid-base interactions. So this type of interaction are actually very important regarding the stability of resulting complexes. Okay, so if you want to form stable, complex, Lewis acid and base adduct complex, you want to have hard acid-base interaction, or you want to have soft acid to soft base interaction to form strong resulting complex. Okay, I hope you guys can understand the broad concept of acid and base. We first talk about Bronsted acid and base, and we move on to a broad concept. We call them Lewis acid and Lewis base, and finally we'll talk about the to define hard Lewis acid, hard Lewis base, and also soft Lewis acid and base. Also, I think I'm gonna stop here, and I will try to prepare another video record for the next lecture, and let me know how do you like that. Thank you.